In this video, we shall look at the connections for a balanced input operation amplifier and discover the major problems in conventional design. If we start with the requirement for the overall gain to be minus G with reference to the in-minus connection, and with the input resistance equaling some value R, then, because the negative input of the op-amp acts as a virtual ground, we can immediately put A equals R and B equals G times R. Now, conventionally, to balance out both sides, we also set C equals R and D equals G times R. But this gives us a problem, because looking into in minus, we see the resistance R as the op-amp negative input is a virtual ground. But looking into in plus, we get the value of C plus the value of D as the positive input of an operation amplifier's high impedance. Let us go back a step and recap. As we see here, we want to see R as a load in both inputs. Now let us rewrite what we know we want. So, to have R for the in plus, we need C plus D to equal R. But we also need D to be G times bigger than C. So substituting for D in the sum equation, we get R equals C plus CG, or R equals C into 1 plus G. And with a quick rewrite, C equals R over 1 plus G. And of course, D is G times bigger. So, now we're good to go. No. Let's look at what the op-amp actually sees. Looking at the op-amp negative input, it sees A in parallel with B. Let us call this Z minus and calculate the value. Now we do the same for the positive input, calling this Z plus. Z plus is smaller than Z minus, so any offset currents in the op-amp are unbalanced, and we need a resistor to correct this. Enter resistor E. Its value is just the difference between Z minus and Z plus, and is reasonably quickly calculated as shown. Finally, bringing the values together and cleaning up the screen, we have this. Okay, all well and good. Let's go for a practical example. For this example, we'll set a gain of 10 and an input resistance of 600 ohms. Well, A and B are easy, as A is the same as R, i.e. 600 ohms, and B is just the gain times resistance, i.e. 6000 ohms. C is a little more complicated, being the resistance divided by 1 more than the gain. D is also fairly simple, it's just the value of C times the gain. Just a quick check, C plus D is 599.999 ohms. It's pretty close to the 600 we want. Now we need the value of E. Let's do this in stages. We calculate the first part, and then the second. Combining, we see E is 600 times 0.826446. Thus E is 495.87 ohms. So, now we have the full design. I hope you enjoyed watching this video. There will be more to follow.